Good morning, and once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to just understand example 9, Pure Mathematics 1, under the very first topics of algebraic expressions, a subtopic named indices. And now that we've learned about indices in the slides, now we want us to practice indices, and the first part of the example is x raised to power 3 divided by x raised to power minus 3. And because we have understood that if you have x raised to power 3 divided by x raised to power minus 3, this is division. So long as the bases are the same, x and x, then it goes without saying that we will have a difference between the indices themselves. So this one is going to be x power 3 minus negative 3. And this one eventually is talking about x power 3 minus a negative means plus 3. So 3 plus 3, x raised to power 6. And that is as far as part A is concerned. Let us talk about part B. Part B is x raised to power a half times x raised to power 3 over 2. This is multiplication, and the first law of indices says that if we have the common base, which is in this case x and x, then we can easily add the indices if the operation between them is multiplication. And in this case, we are talking about x raised to power a half plus 3 over 2, meaning a half plus 1.5 is 2, and therefore x raised to power 2, and that is the answer. Let's go to part C, whereby we are talking of x raised to power 3, upon which we raise it to power 2 over 3. And we have also understood that in such a case, when we have a base that is raised to a certain power, and again the whole arrangement is raised to another power, this is the same as finding the product of the power x raised to power 3 times 2 over 3. 3 times 2 over 3 is simply 2, because 3 and 3 will cancel out. And this is simply the final submission. That is as far as part C is concerned. Part D, if you look at part D, we are having something to do with 2x raised to power 1.5 divided by 4x raised to power negative 0.25. Well, there is nothing difficult here, because this is division. And of course, we can rewrite this one in form of 2x 1.5 all over 4x negative 0.25. So that now we can look at it from that perspective. The constant is 2 over 4, which is basically a half. This is 1 over 2. X raised to power 1.5 over x raised to power negative 0.25 is the same as x raised to power 0.5 minus negative. When we subtract a negative, then it's the same as talking of addition, 0.25. And at the end of the day, this is not 0.5, this is simply 1.5. I beg your pardon there. And eventually what we are realizing this to be is a half x raised to power 1.5 plus 0.25, which is 1.75. And that is the final submission. as far as part D is concerned. Let us talk about part E. Let us talk about part E. Part E is the cube root or the third root of 125 x raised to power 6. And as you expect, we should get the cube root of the whole number, which is now the cube root of 125 multiplied by the cube root of the unknown part multiplied by the cube root of x raised to power 6. You may put a bracket in between them because they're actually being multiplied out. And we look for the cube root independently. The cube root of 25, all of us know this is 5. This part is going to give us 5. And as you know, the cube root of x raised to power 6 is the same as x raised to power 6 multiplied by 1 over 3, because the cube root means power a third. We have looked at this differently and you have seen it, how it works. Now we have x raised to power 6 times a third. The product of the two indices as seen here, we are going to have 2. So eventually we're going to have 5x squared. And that is the very final submission. As far as part F is concerned, let me just work out part F here. Part F is going to be 2x squared minus x, everything over x raised to power 5. And we expect that because we have x at the denominator, this denominator is shared by each of the term in the numerator. So we need to separate the terms and have 2x squared over x raised to power 5 minus x, this is to power 1, all over x raised to power 5. And what this gives us is, this is 2, this is going to be 2 x raised to power 2, and because we have x squared divided by x power 5 minus 5, division says that we have the difference of the indices, minus x raised to power 1 minus 5. So eventually we have 2 x raised to power minus 3, because 2 minus 5 is simply minus 3. Subtract now x raised to power 1 minus 5 is negative 4. And there is nothing we can do about that. We can only write it now back into fractions, which is going to give us 2 all over x raised to power 3. Remember, when x now finds its way back to the denominator position, of course, and vice versa, also to the numerator position, the sign of the index will automatically change. So this is 2 over x raised to power 3 minus, of course, we have a 1 there, all over x raised to power 4. Again, the same change of sign of the index at the denominator position takes place. So finally, that is now the final submission. That is now the final submission as far as all those examples are concerned. So basically, if I may want now to summarize the laws of indices here, we know that a raised to power x times a raised to power y, this is a raised to power x plus y. A raised to power x divided by a raised to power y, this is a raised to power x minus y, and you know it. A raised to power x over y, this is the y root of a raised to power x. And vice, of course, we all know that a raised to power 0, any number raised to power 0 is simply 1. And so on and so forth. Finally, if we have a raised to power x, again raised to power y, this is the same as a raised to power xy, the product of the two. I hope you remember, and let us meet in the next video.